Hey there, welcome to WEBfactory. My name is Alex, and I would like to show you the new geolocation feature we've implemented in i4connected. With the latest version of i4connected, you can now use geographical data coming from your devices to track their location on the map and trigger or suppress alarms based on this location. You can use this to track your moving assets, maybe your power generators that you ship to your customer's location, or maybe construction equipment for wind parks moving around the world from park to park. Once you have your asset's location, you can set up geofences, monitored geographical areas which can trigger alarms when the asset leaves them or suppress alarms when the asset enters them. Alright, then let's take a look on how easy can we set up this functionality. There are many possibilities to get the geolocation data in the system. For example, if you use a data gateway such as the Argus Netbiter, it has integrated GPS location information. To make things interesting for this demonstration, I will be using Node-RED to get the location data of the International Space Station, which is publicly available. As the IIS is moving very fast, it's a nice example because we will see rapid location changes. I'll quickly show you the flow in Node-RED just to give you an idea. By using the ISS location node, we get the location every 10 seconds, add the current timestamp, and then send it to i4connected using MQTT. In i4connected, the geolocation data consists of two signals, one for the latitude and one for the longitude. So first we need to create a new device for the International Space Station and set it to use an MQTT adapter. I'll create a new adapter for our device and set it to retrieve the data from my MQTT broker. Now we can add the new signals. First, I'll add the latitude. Since I know my MQTT payload contains the lat and lon values for coordinates and the time value for the timestamp, I'll set the value to lat and the timestamp to time. Then I'll define the longitude signal in the same way. I can check out my signals and see the online values coming from my MQTT broker, so I know my configuration is right. Now we need to define the signals as coordinates. I'll go to the device configuration and check the GPS tracking fields button. I'll enable the GPS tracking and select the signals for latitude and longitude. Now I can go to the device map and instantly see the location of the ISS. From here, I can select different time spans to see the geographical path history. So you can easily track the location of your devices, but we can also add fences to trigger and suppress alarms. Let's have a look at that. First, I'll get the coordinates of the current ISS location, since I want it to be inside my new fence initially. Back in the GPS tracking fields information, I can add the first fence. I'll give it a name and leave the type at circle and radius. Let's add the coordinates for the fence. I'll just paste and fix them in the appropriate fields. I'll make a large radius for my fence and set it to trigger an alarm when the device leaves the fence. I'll create a new alarm, set it to manual, configure its priority and type, and assign it to my fence. Back on the device map, we can now see the fence added to the map. The ISS was initially inside my fence, but since it's moving so fast, it's already left our fence. And that's a perfect scenario to see how my alarm was triggered by the ISS leaving the fence. But that's not the whole story. I can also set up another fence that will suppress this alarm. Since I know the path of the International Space Station on the map, I'll grab a set of coordinates which I know will be reached by the station. Then I'll go back into my device's GPS settings and create a new fence. This new fence will suppress our defined alarm once the ISS enters its radius. Going back on the device map, I can now see both my trigger fence and my suppress fence. As the space station moves along its path, it will cross the border of my second fence, which in turn will suppress the alarm that was triggered when the space station left the first fence. I hope you liked the quick demonstration of the GPS location functionality in i4connected. Get in touch with us if you want to try it yourselves. I'm Alex, this is WEBfactory, and as always, keep an eye on our channel. There is more to come.